Hi my friend, welcome to Joystick. In this video of Joystick, we are going to solve the longest palindromic subsequence using dynamic programming. This video is in extension to the video in which we worked upon developing the intuition to solve the longest palindromic subsequence problem. I highly recommend you to watch that first and then come back and watch this video. So without wasting any more time, let's revisit the problem statement. So there is a string given to you. In our example, we are going to work upon the string CBEDFEB. We have to find the length of the longest palindromic subsequence from this string using dynamic programming technique. In case you do not know what a palindrome is, then it's a string which is the same when read from the right as well as from the left up to the center or pivotal character. The examples are radar, level, rotor, etc. Now, the longest palindromic subsequence in this string on which we are going to work upon, which is CBEDFEB, is going to be BEDEB. That means the length of the longest palindromic subsequence is 5, and in our solution we are also going to find the components of the palindromic subsequence. So now let's move to our framework where we are going to solve this problem. Before moving to our framework, I request you to subscribe to my channel if you haven't done it till now, and just hit the bell icon so that you get notified whenever I release videos like this. So here we are at our framework. As you can see, we'll fill this entire matrix just to get the length of the longest palindromic subsequence, and using the components of this matrix or the values filled in this matrix, we are going to determine what that palindrome is going to be. All right, now here is the list which we created in our earlier video where we worked upon developing the intuition. All right, and in that list, while writing the last point, I told you that we are going to check if length is the driving force. So here we are going to start from length 1. That means each individual letters of this string, okay, we are treating it as the longest palindromic subsequence. So we'll work on first filling the base state, and that base state is going to be the LPS of each of the individual letters. Right now, as you can see that we cannot go in this direction. That means we cannot fill each of these cells because that is going to do injustice to our thoughts, because we are checking for the palindrome. That is the condition over here. So in order to fill the base state, the letter over here is going to be the same as letter over here. So here C is equal to C. So I'm going to put 1 over here, which is the length, which is going to be the length of the longest palindromic subsequence. Let me do some formatting for you so that it stays clearly visible. Now, for the second subproblem, which is going to be B, I cannot put 1 over here because C is not equal to B, and that is not going to make sense. When we are focusing on individual subproblems, it has to be B equivalent to B, which is this cell. So I'm going to put 1 over here. Let's check like that. All right, here E is equal to E, so I'm going to put 1 over here. Similarly, I'm going to fill all these cells which are laid out diagonally with 1s. All right, so this makes our base case. Okay, now we are going to increment our length by 1. So it's going to be CB. Now these two we are going to consider. So first check whether C is equal to B. Is C equivalent to B? No, right? That means we are going to apply this formula at point number 4. Formula to find length when it is not a palindrome. So it is going to be max of length of C. That means the length of LPS of C and length of LPS of B. So as you can see that the length here of LPS of C is 1 and that of B is 1. So max of 1 and 1 is going to give us 1. All right, I think that we are progressing in the right direction. Okay, now the second subproblem is going to be BE, right? Because we are progressing, okay, in the order of lengths, and the length currently is 2. Cool. So BE, that means maximum of LPS of B and maximum of LPS of E. We are going to apply point number 4 here because B is not equal to E. All right, so 1 is the LPS of B and 1 is the LPS of E over here. Hence, I am going to get the maximum value as 1. Similarly, over here, the subproblem is going to be E and D. So max of LPS of E is going to be 1 and max of LPS of E is going to be 1 and that of LPS of D is going to be 1 as well. So max of 1 and 1 is going to come as 1. Cool. Now the subproblem becomes T and F. So max of LPS of D and LPS of F, that is going to give us 1 again. Similarly, we are going to get 1 over here and 1 over here. All right. Now the length is again incremented by 1 and it becomes 3. So the subproblem becomes CBE. Now point number 4 again applies to this subproblem because C is not equivalent to E. Hence, it is going to be the maximum of CB, which is 1 again, and BE, which is 1 again. As you can see, this is BE, so this is the value. This is the optimized solution of the subproblem BE. Think it that way. All right. So maximum of 1 again going to give me 1. Okay, I think we are progressing very well and I am sure that it is now clear to you. Now this is going to be BET, the next subproblem. So it is going to be the max of BE and ED since D is not equal to B. All right, so E is 1 and ED is 1. Max of 1 and 1 is going to be again 1. All right, we come down here, EDF. It's going to be max of ED, LPS of ED and LPS of TF. So 1 and 1. Okay, TF is 1 and ED is 1. So that is going to come out as 1 again. Similarly, I am going to get 1 as the cell values of the next few cells. All right, because we all have ones. Now this determines that at any point of time, like if we have the subproblem as BET, then 1 is the answer, 1 is the LPS. Okay, think it that way. Check every dynamic problem in terms of subproblems. It's going to make a lot of sense to you and then the solutions will start occurring to you automatically. Okay, now the length becomes 4. So the subproblem becomes CBET. All right, which is going to be the max of CBE and BED. Point number 4 again applies here because C is not equal to D. All right, so LPS of CBE is 1 and that of BED is 1 again. So I am going to get 1 as the answer over here. Similarly, BEDF, P is not equal to F. So LPS, max LPS of BED, that means the optimized solution of BED is 1 and that of EDF is again 1. So I'm going to get 1 again. Okay, now EDFE. So EDF, now here E is equivalent to E. All right, that means point number 4 is not going to apply over here. Okay, when we are finding this cell value, point number 4 is not going to apply over here. Point number 5 is going to be applied over here because now we have a case of palindrome. So what was point number 5? Point number 5 is going to be 2 plus, that means the length of this E and this E, which is going to sum up as 2, and the max LPS, the longest palindromic subsequence of TF. So what is TF? The LPS of TF is 1. So 1 plus 2 is going to give me 3. Okay, note this down that for EDFE, I am getting the LPS as 3. That means the longest palindromic subsequence as 3. All right. Now we move to DFEB. Now D is not equal to P. Okay, so again it's going to be point number 4, max of DFE and FEB. All right, so I am going to get 1 again over here. Cool. Now the length increases to 5. So CBEDF becomes our subproblem. So that means C is not equal to F. So point number 4 will be applied here, which is going to be the LPS of CBED and BEDF. So CBED is 1 and BEDF is 1. So I'm going to get 1 over here. All right. Now the subproblem is going to be BEDFE. B is not equal to E. So it is going to be the composition of the subproblems BEDF and EDFE. So BEDF is 1, but EDFE is 3. So max of 1 and 3 is going to be 3. All right. Now EDFEB. So this is going to be the composition of subproblems EDFE and DFEB. DFEB is 1, but EDFE is 3. Max of 3 and 1 is going to give me 3. Okay, cool. Now the length increases to 6. All right, CBEDFE becomes our subproblem. So which is going to be a composition of subproblems CBEDF and BEDFE. So BEDFE is going to be 3 and CBEDF is going to be 1. Since C is not equal to E, hence we are going to take the maximum of 1 and 3, which is going to give us 3. All right. Now BEDFEB is our next subproblem. So B is equal to B here. That means we are going to add 2 to the LPS of this subproblem, which is EDFE. So EDFE is 3. 3 plus 2 is going to give me 5. Okay. Now our length increments by 1. It becomes 7, which also happens to be the length of our string, the final length of our string, the original length of our string. So we have come to the end of our problem. So CBEDFEB becomes our next subproblem, which also happens to be our problem, which is going to be a composition of CBEDFE and BEDFEB. So CBEDFE is 3 and BEDFEB is 5. Since C is not equivalent to B, hence point 4 will be applied here, which is going to be the maximum of 3 or 5. So I get 5 here as my answer, and this becomes the length of the longest palindromic subsequence of my string. Now we'll work on finding the components which are forming this palindrome. Okay, so we are going to start from here, the final cell. Now this 5 is coming from this 3 or this 5. It is coming from this 5. We are getting this 5 from this 5. So we are not going to consider this cell. Rather, we are going to move one step ahead. Now this 5 is being formed from this 3. Means here point number 5 was applied. All right. So B is going to be my first component, and since we are talking about palindrome, hence it is going to be on the other side of the string as well. Okay, let me see if it is a string of length 5. All right, so I'll have to shift it one cell to the left. Cool. Now, all right, so let me color this up. This 3 is also coming from this one. Okay, that means point number 5 has been applied here as well. So my next component becomes E. And since I'm putting E over here, I'll have to put it over here. Now the final component remains. Now this one is coming from either this one or this one. All right, so I can go in both direction, and after that, okay, this is the final letter. Okay, either this or this. So either D or F is going to be the final letter of our palindrome. So I like D, therefore I am going to choose D. And this becomes our longest palindromic subsequence, like we discussed in our slide. Now let's move to finding the algorithm. So here we are at the algorithm. If Ti is going to be equal to Tj, if Ti equals Tj, then Tij is going to be 2 plus Ti plus 1, Tj minus 1. That means we have to look diagonally left and then add 2 to it. Else, if they are not equal, then point number 4 will be applied, which will be Tij maximum of Ti plus 1 j and Tij minus 1. That means cell to the left and one cell down. All right, the time complexity of this dynamic programming solution of LPS is going to be O(n) square. So with this, we have come to the end of this video. I am sure that you have enjoyed watching this video. If you like this video, then do hit the like button. Please subscribe to my channel if you haven't done it till now. I look forward to helping you with algorithms and programming. Thank you and goodbye.